Hey guys, we're just going to talk about different function notation and what vocab is necessary to do it. So the first thing is if they give me a graph, they're going to ask what the domain and range is. Domain is how far left to right something is. So I'm just going to follow this arrow until it stops going left, which is never. So I'm going to put negative infinity, and how far right it'll go, which is also never. So I'm going to put positive infinity. I'm going to put these soft parentheses. Parentheses tell me that the number is actually not achievable. So I can't achieve infinity. So I'm going to get super close but never actually touch it. Range is how far up and down something goes. And I always go down to up. So I go down for forever and up for forever. If I'm given negative and positive infinity, I can rewrite that as all real numbers, and that's what this symbol means. So the domain and range for this graph is all real numbers. If they give me something that looks like this, for example, we will start with domain. And so let's say that this is -3 and this is 4. How far left does it go? It goes to -3. And then to 4, it gets super close to 4, but because of this open dot, it doesn't actually achieve 4. So I'm just going to leave it as parentheses. And then let's say that this was 2. My range would be how far down does it go? 2. And how far up does it go? Because of this arrow, it's going to keep going up for forever. So even though it stops right here, and it keeps going up for forever this way, we're going to say to positive infinity. And then I have a dot, an arrow going this way. Let's say this is 1, this is 2. My domain would be from 1 to positive infinity, and it's a bracket because the 1 is filled in. And then my range is from 2 to infinity. Okay? What I did with the brackets in the parentheses is known as interval notation. Sometimes, though, they might do something like, let's say it's 1 to infinity. They might write it as 1 or equal to x, which is to infinity. A soft bracket is just a greater than or less than, and a hard bracket is an or equal to. So if they give you something that says like -4, soft bracket to +6, hard bracket, you would say from -4 is less than x, which is less than or equal to, because of the bracket, it's or equal to 6. Okay? How do we know if something's a function or not? If they give us a bunch of data, we just care about the x terms, and if we have no repeats, then that means yes function. So no repeats, yes function. If we have repeats in x, that's all that matters. Okay? So yes, there's a repeat in y, but we don't care about y. So if there's a yes to a repeat, that means no to a function. Okay? If they give us a graph, though, and say, is it a function? Okay? I just draw a line straight down. It doesn't matter where. If it crosses only one time, then yes function. But if I go straight down and it crosses more than once, we say no a function, because that's a repeat in x. Because on my x-axis, I have 2 numbers that would appear. All right? Let's say that they give us an equation, x plus 2. Then they say evaluate where f is 1. I'm just going to replace where there's an x with the number. But if they give us something like x plus 2, I'm still going to replace x with my new number. But my new number now is x plus 2 plus 2. So x plus 4 would be my final answer. And then if they gave me something, replace f of x with negative x squared, I would replace x from the original with negative x squared plus 2. And this would be my final answer. And then evaluate when given a graph. So they might say at f is 4, evaluate. So that means where x is 4, 1, 2, 3, 4, I go up to my graph and say 1, 2, 3, 4, 5. So f of 4 is equal to 5. Yes, what they're asking for is, when I give you the x value of 4, what does y equal? If you have any questions, email me.